So this video is on 8.1.2, which is Chapter 8, Classwork 2, worksheet. Okay. But before I discuss this, we had a another classwork that day, which was notes. So I'm going to get the notes up. I have a completed copy online, but I'm going to run through it and explain it in this video before I go through the assignment. So for this was notes on graphing polynomials. And what we first were learning is how to discover what degree a polynomial is. Now, when you're trying to find the degree of a polynomial, the first thing we need to kind of understand is that if I'm trying to find the degree of a term, okay, which is this side of these two columns, it is the sum of the exponents of your variables. So this one here, this 6x to the 8th, there's an x to the 8th, that's the only variable, it is degree 8. This next one is a monomial also. You have an x to the 6th, you have a y to the 3rd, and you have a z really to the power 1. So you're going to take your 6 plus 3 plus 1, 6 plus 3 plus 1, and you get 10. This one here is a number, it's also a polynomial and a monomial. This is degree 0. Now you can really kind of think about this as being really x to the power 0. And that's where that degree 0 is kind of coming from. Okay. Now, when we are talking about the degree of a polynomial and not just a single term, okay, what we're going to do is we are going to look at the degree of each of the terms, and then we are going to find the term that has the biggest degree, and that's going to be the degree of the polynomial. So in this case, this one right here, this term is a degree 5. This term right here is a 6, 3, 1, so it's a degree 10. This one here is a 5, 2, and 4. When we add that together, we get an 11. So this whole entire polynomial is degree 11. Now, that's when it is multiplied out. So just kind of as a quick little example, let's say I have an x to the 4th plus an x to the 3rd plus an x to the 2nd plus an x plus a 1, where we have all of these terms. The term with the biggest power is going to be this term, so that would be degree 4. Now, when it's not in that type of a form, it's in a factored form, we do it slightly differently. So what we're going to do is we're going to find the term of each of these factors. So we have this factor, and this factor. And so what we're going to do is we're going to find the degree of each of them. This is degree 1, and we're going to add it. The next one would be degree 2 because of that square. And then the next one would be degree 1. So this entire thing would be a degree 4. So on the next one, again, it's going to be similar here, here, and here. Oops, change the color. So for this one, this is degree 1. This is also degree 1. And this last one's degree 1. So this is going to be a degree 4. Now we did fill this in on Tammy, and we submitted this as an assignment. Okay. So you want to do that, make sure you get those points, easy points, just copying down what I'm doing. I also have a finished version in Canvas. Okay, so if I'm looking at each of these, this first one's degree 1. This next one, because of this x squared here, this is actually going to be degree 2. Now, this one isn't an x squared here, but it is squared here. So that's also going to be a degree 2. So this whole entire thing is going to be degree 5. Okay, the next one, we've got 1, 2, 3, 4 different factors here. So this one's going to be 1. This one's going to be 1. The next one, because of that squared here, is going to be 2. And the last one's going to be 1. So this is going to be degree 5 also. Okay, these last ones. Okay, this one we have these 2. So because of the square here, this is going to be degree 2. The next one's going to be degree 1. So this is going to be degree 3. And the next one, we have this x plus 3 squared. And we have this x minus 1 squared. So this one's a degree 3. This one's a degree 2. So this whole entire polynomial is degree 5. Now, the reason this is important is because this is going to help tell us the shape of the graph. Okay. So when we're talking about polynomials, we talk about them in terms of their degree. And here's some examples of different degrees. Degree 1 is linear. Okay. So a positive line is increasing. Notice it starts below and ends above. So the end behaviors, we talk about end behaviors. This one's going to go down forever on the left side and go up forever on the right side. So that's our end behaviors. On the next one, this is degree 2 polynomial, which is a parabola, and a positive parabola opens up. So it's going to go up forever on the left and up forever on the right. So the end behaviors are up and up. For a degree 3 is a cubic. Now we're used to most, the cubics we've been seeing originally were like this. Okay, this one's a little different than that one. But again, in both cases there, you see it is going down on the left side and then going up on the right. So it's starting and stopping in opposite directions, just like the degree 1 did. My even one started and stopped in the same direction. This is degree 4, an example of a degree 4. And you'll notice it's starting and stopping in the same direction, just like my degree 2. And so its end behaviors are up. And that is going to be true for my degree 2, my degree 4. Any even is going to be like these. Any odd is going to be like these. So here you see a degree 5. You see it's going down on the left side and up on the right side. Down on this side, up on this side. So starting and stopping in opposite directions. So to summarize here, all of our evens, okay, I think of them as evens almost like a parabola, okay, where if it's an even degree and it's positive, it's going to go start above and end above, okay. So my end behaviors for this are going to be up and up. That's the end behaviors for this one. Now, if it's an even, but it's negative, that's like an upside down parabola. So my end behaviors are going to be down and down. I'm going to be starting below and ending below the x-axis. Now, when we're dealing with odds, if it's a positive odd, here they're showing you an x cubed and a negative x cubed. I generally think of this as a positive line as an example. So if I'm thinking of a positive line, that would be an increasing line. This, a negative line, would be a decreasing line. So you'll notice that if it's a positive and it's odd, whether it's this cubic one or this line, it's starting below and ending above, starting below, ending above. So this behavior is going to be down and up. Okay. Now, when it's a negative odd, it's a decreasing line. Okay, so it's going up forever here, down forever here. Same with the cubic. So this is going to be the reverse. Now, again, all of my odds are going to start and stop in opposite directions. All my even degrees are going to start and stop in the same direction. Whatever's happening to the positive, the negative is going to be flipped. So these are both up, these are both down. Here, this was down and up, and now it flips. So that's going to help us also with these graphs. So when we're graphing these, we're not going to be accurate with them. We're doing a sketch. We are sketching, basically concerned about where it crosses the x-axis, how it, we call those roots, how it crosses the x-axis, and the end behaviors. So when I'm looking at this, I'm going to look and go, okay, what degree is this going to be? So this is going to be a degree 1, degree 1, degree 1. So this whole entire thing is going to be degree 3. And then I need to decide if it's a positive or a negative. So looking out front, there's no negative out here. So this is going to be a positive degree 3. And a positive degree 3, if we look here, okay, a positive degree 3, positive odd, is going to be starting below, ending above. Okay. So my end behaviors are going to be, oops, let me make it a little neater. Like this. Okay. So the next thing I need to do, I need to find my roots. So my roots are going to be what makes each of these 0. So really I'm setting this to 0 and I'm solving using the zero product property. So what makes this first one 0 is a -1. And that's going to be a single root. My next one is a 3. That's going to also be a single root. My next one's going to be 4, and that's going to be a single root. Now, you'll see what happens with a single root. So when I draw this, I'm not going to scale my y-axis because I'm not concerned with how high or low. I'm just concerned with sketching it. So I'm just going to scale my x 1, 2, 3, 4. 1, 2, 3, 4. And I have x-intercepts at -1, and that's a single, at 3, and at 5. Now, I see that this has to be starting below and then ending above. So what's going to happen is I'm going to start below. It's going to come and go through this because it's a single root. It's like a line going through. It's going to come up. I don't care how high. I'm not going to be judging that right now. And it's going to go through again like a line. And it's going to come back up and it's going to go through this like a line. And there's my graph. So on the next one, this is going to be degree 2. This one's going to be degree 1. There is a positive, well, no negative out here, so it's going to be positive. So this is going to be a positive degree 3. And just like the one above, that means it's going to start below and end above. That's my end behavior. Now, what are my x-intercepts? I'm going to have 2. For the first parenthesis, again, I am setting this equal to 0. And this one is a double. A double, and that's going to be important for how it crosses the x-axis. And then the other one right here, that's going to be a -3, and that one's a single. Okay. So when I graph this, 1, 2, 3, 1, 2, 3, and I have at -3, and I have at 2. And when I'm doing this, again, it's going to start below. And what happens is that -3 is a single. So it's going to go through like a line. And then when I come to the next one, which is a double, it's going to be like a parabola. It's going to bounce off. That's what all double roots have look like. It's not going to go through. It's going to come and bounce back. Okay, the next one. This is degree 1. This is degree 2. This is degree 2. It's a positive, so it's going to be a positive degree 5. Okay, so that again is another odd and positive, so it's going to start below and end above. Okay, that's going to be the That's going to be, sorry, that's going to be the end behavior. Now, if I set if I set this to 0 and I'm solving, this is going to be 0, which is a single. This one's going to be -1, which is a double. Let me just write double here. And the next one's going to be a +4, and that one's also going to be a double. So what's happening here is for this, I am going, and the end behavior is like the one above. So let me just get this 1, 2, 3, 4. 1, 2, 3, 4. Okay. And I have at 0, and I have at -1, and I have at 4. Now I'm going to kind of highlight these. This one here, my -1, and this one here, my 4. Those are doubles, so it's going to be bouncing off. So when I'm graphing this, again, it's going to start below. It's going to come, and it's going to go and bounce off of this because it's a double root. It's going to come back up and go through because it's a single root, and then like a line. And then the other one is going to be a double, so it's going to bounce off like a parabola again. Now, this next one, we have a 3 for this one. We have a 2 for this one. So this is going to be degree 5, but there is a negative out front. So it's going to be a negative degree 5. So that means what's going to happen is it's going to be going, sorry, that's what it normally would go. It's going to be the reverse. It's going to be like a decreasing line. It's going to be starting above, ending below. Okay, so it's going to be going up on the left side and down on the right side. So this is going to be my end behaviors. And when I am finding my roots, this first one's going to be -1, not because of the negative out front, but because that's what makes this 0. The negative out front does not affect the parentheses in terms of what makes them 0. So this -1 is a triple, and I'll show you what that looks like here. And then this other one is a 1, which is a double. Okay. Now a triple is going to look like a cubic graph, which is almost like if I have my inflection point, let me just draw my inflection point here. It comes like almost like an open down parabola, and then it stops, and then it changes to like an open up parabola. So it changes from being concave down to concave up. Now, if it's going the other direction, okay, and I'm starting above, then it's going to be like an open up, half of an open up parabola, and then it turns to half of an open down parabola. So that's what's going to be happening at the x cubed. So if I draw this one, I basically only have 1 and -1. Okay. So for this one, I have a point here and I have a point here. Now I have to pay attention. This one here was my double, and this one here is my triple. Okay, so I just want to pay attention. And this is going to be starting above. So as it comes above, this being the triple, it's going to be coming again like an open up parabola until it gets to there. And then it changes to almost like half of an open down parabola. And then it's going to come here to this. And this root is a double, so it's going to bounce back like a parabola. And that's your graph. So I'm actually going to make a second video that is on the classwork 8.1.2. And so I'm going to put that on that classwork in Canvas.